So hi everyone. So today's topic is about number systems. So before going to the number systems, you should know what is mean by digital electronics. So what is digital electronics? So it is nothing but a study of electronic circuits. Study of digital circuits we are calling as digital circuits. So what we are going to learn in this digital electronics? So we are going to learn about number systems, Boolean algebra and logical gates, minimizing techniques, combinational circuits and sequential circuits. So these are the things we are going to learn and these are the things we are going to cover in this digital electronics. And before going to that, so what is mean by signal? So signal is nothing but a information carrier. So what it is going to do is it is going to carry some information from one device to another device. So it is going to carry some information from one device to another device. So the thing we call as signal. So these signals are mainly classified into two types. So one is analog signal and one more is digital signal. So what is mean by analog signal? So analog signals are also called as continuous signals. So why we are calling these analog signals are continuous signals? Because their value change from every instant of time. So for every instant of time, their value is getting changed, right? So since we are calling analog signals are called as continuous signals, and for analog signals, it is in form of sine wave form. It is there in sine wave form. Analog signals are there in sine wave form. And coming to digital signals we are called as discrete signals. Discrete signals. So why we are calling digital signals is so because it can show information in zeros and ones. So rather than this, it can't show anything. So for analog signals, it's the way signals are there in form of square waves. Okay. But whereas coming to analog signals, it is there in sine waves. Where coming to digital signals, it is there in form of square waves. So what was the difference between analog signals and digital signals? Analog signal is a continuous and time varying. So but every instant of time, analog signals are changing. But we're coming to digital signals, they have only two states, 1 and 0. And these digital signals are also called as binary signals. These digital signals are all called as binary signals. And the second difference is analog signals is usually in form of sine waves and digital signals are usually in form of square waves. This is a second difference. Analog signals are in form of square waves, sine waves, digital in form of square waves. And third one is analog signals are mostly affected by the noise and these digital signals are less affected by the noise. This is the third difference. And the fourth will comes analog signals are continuous value representing the data. Digital signals are discrete value to represent the data. That means it is form of discrete zeros and ones. It is form of sine waves. And the fourth one is accuracy of analog signals may be affected by the noise and accuracy of digital signals are minimizing from the noise. So these analog signals are mostly affected by the noise and digital is we can remove that. And so the examples of analog signals are temperature and pressure. And we can also say that frequency. Frequency it is form also in form of analog signals, right? Sine waves. These are temperature and pressure are the best examples of analog signals, and computers and CD are the examples for digital signals. And coming to the components of analog signals are resistors, capacitors, diodes are used in analog circuits, and whereas coming to digital circuits, transistors, logic gates are used in digital circuits. So this is all about analog and digital circuits. The next one is about number systems. So what is a number system? Representing of a number we are called as number systems. So what a number represents? A number in digital electronics represents some information. So the number represents some information we are called as number systems. So based on how we are based on the radix, so how we are going to see the number system. So we have a we in number systems we have several types of number systems. So how we have classified those number systems is based on the radix. That is nothing or base. So based on the radix or base, we are going to classify our number systems. So mostly they are classified into four types. So one is binary number system, and the second one is octal number system, and the third one is decimal number system, and the fourth one is hexadecimal number system. So based on the radix, the number systems are classified into four types. So one is binary, and another is octal, and one more is decimal, and the last one is hexadecimal. So these are the four major number systems. So what does binary is going to represent? It is going to represent in the values from 0 and 1. So it is going to represent only two values, zeros and ones, and the radix of it is 2. So the radix of binary number system is 2. And next second one is octal, right? So it is going to represent the numbers from 0 to 7. So for 0 to 7, the radix of it is 8. So that means 7 power 8 or 6 power 8. 6 to the base 8 or 5 to the base 8. So as like it is going to represent a number. For binary number systems, it is going to represent 0 power 2 or 1 power 1 0 base 2 or 1 base 2 as like it is going to represent. And the last one is decimal number system. So for how it is going to represent? It is going to represent from 0 to 9. Decimals are going to represent from 0 to 9. So and the radix of decimal number system is 10. And the last number system is hexadecimal number system, right? So it is going to represent from 0 to 9 comma a b c d e and f. So these are the values it is going to represent. So it is going to represent these numbers 0 to 9 comma a comma b c d e and f, and the radix of it is 16. So the radix of a hexadecimal number is 16, and a represent 10, b represent 11, C represent 12, D represent 13, E represent 14, and F represent 15. So these are the things, these are the different types of number systems we have. And decimal is going to represent with 10, binary is represent with 20, octal is going to represent with 8, and hexadecimal is going to represent with 16. So conversion of number systems. How we are going to convert our number systems from one to other. So how we are going to represent. So how I am going to convert is, so we have certain rules. So first one is conversion of decimal number system is binary. How I am going to convert my decimal number system is decimal number system to binary number system. So here I have one question. 24.12 of 10 is equals to x of 2. So what was the radix number of binary number representation of 24.12? So for this, what I'm going to do is, I want to divide my decimal number system by 2. So how many times I can divide in 24? 12 times, right? And what was the remainder of it? It is 0. And 2, how many times I can do for 12? So it can divide for up to 6, right? And the remaining is 0. And next one is 6, right? 6 to how many times it will go? It will go to how many times it will go? It will go 3 times, and the remainder is 0. And again, to how many times it will go? It will go 1 time, and the remainder is 1. So this is the thing we got, right? So how 24 is getting represented in decimal format is, we need to go in bottom to up format. So here it is 1, and next value is 1, and here it is 0, and for 6 it is 0, and for 12 it is 0, right? 0. So this is a representation of decimal number decimal number 12 in binary format, and I have point 0.12, right? I have 0.12. I need to convert these 0.12 in binary format. For this, what I am going to do is I am going to multiply this number with 2. So how many times it will go? It will go 0 to 4 and 0 to 4 into 2. How many times it will? What was the value of it? 0.48, right? And 0.48 into 2. How many times? 0.96, right? And 0.96 into 2. What was the value I'll get? 1.92. So until I get a decimal number, until I get any number rather than 0, I need to multiply my number. And for 0.12, what was the value I got? I need to go in top to bottom format. Here 0.001. 0.001. So this is the binary number I got for 0.12. That means 24.12 of 10 equals to 1100 point. So after point, what was the value I got? 0001 of binary number. So like this, we are going to convert my decimal number to any another number. If you want to convert your decimal number to any another binary or hexadecimal or octal format, we need to follow this procedure. Okay. So the next conversion is the same. Second one, 24.12 of decimal number. I want to convert this decimal number into octal format. How I am going to convert is just 24 is multiplied, it's divided with 8. So how many times it will go? 3 times, and the remainder you will got is 0, right? So for 24 of decimal number, so what was the octal number of it is 3 and it is 0, right? 30. 30 of or to the base 8 and 0.12 is getting multiplied with 8. How many times? 0.12 into 8. 96. 0.96 and 0.96 into 8. How many times it will go? So what was the value we will get for 0.96 into 8? 7.68, right? 7.68. So until I'll get some other value rather than 0, I need to do multiplication, right? I got here some value 0.128 of decimal number equals to 0 0.07 of your octal number. That means while combining these two, 24.12 of decimal number equals to, so what was the value you got? 30.07 of your octal number. So this is how we are going to convert our decimal number to octal number. Okay. And the next one is same number. 24.12 of decimal number. I want to convert this decimal number to 16. That means hexadecimal number. How I am going to 24 is getting divided by 16. How many times it will go? It will go at only once. And what was the remainder you will get? You will get 8 as a remainder, right? That means 24 representation of 24 in uh, hexadecimal format is 18. 18 of what number? 16 number. And 0.12 into 16. What was the value you will get? 0.12 into 16. 1.96, right? 1.96. Just I got value 1. So that I can end up to here. 0.12 of decimal number with representation of hexadecimal number is 1. 0.1 of 16. That means 24.12 of decimal number representation in hexadecimal format is 18.1 of radix 16. So like this we are going to convert my decimal number to any another form. So the next one is conversion of any other form into decimal number. How I am going to do that? So for this I need to follow some procedure. So first one what I'm going to do is I will convert my binary number to decimal conversion. So for this what I'm going to do is I have a number called 1100.0001 of radix 2. I need to convert this number into decimal form. How I'm going to do is so 1100, right? So for this number I will multiply 0 from this is my weight from I will start from here and I will go this side. So 0 into 2 power 0. So this is in binary format, right? 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3. So what was the value I got? 0 plus 0 plus 4 plus 8. That means 16. So not 16, 12. So I got 12 of my decimal number. And I need to show for 0.0001 also, right? 0.0001 of your binary number. I need to convert this number into decimal format. For to represent 0.001, I need to go in this format 0 into 2 power minus 1 plus 0 into 2 power minus 2 plus 0 into 2 power minus 3 plus 1 into 2 power minus 4. That means 0 plus 0 plus 0 plus 1 into 1 by 16, right? And is equals to what was the value you will get? 1 by 16. 1 divided by 16. 0.065, right? 0.0625. That means representation of 0.0001 of binary number is equals to 0.00625 of your decimal number. So the next thing what you want to see 1100.0001 of your number in order to convert it into decimal form. So what was the value you got for 1100, you what the value you got? 12, right? 12 point. And what was the value you got for 0.0001? 0.0625, right? 0.625. So this is how we are going to convert our any number to decimal format. So the next conversion is octal to decimal. Octal to decimal. So how I am going to do this? So my octal number is 625. Of my octal number, I need to convert this number to mm, decimal format. For this, what I am going to do is, so I am going to multiply this number with 8 powers. That means 5 into 8 power 0. That means for this first bit, I am going to add power 8 power 0. That means I am going to add some weight to this. That weight is 8 power 0 plus 2 into 8 power 1 plus 6 into 8 power 2. So what is 5 into 8 power 1 is 1 plus 2 into 8 plus 6 into 64. So 5 plus 16 plus 64 into 6. So what was the value you will get? 64 into 6 will get 384, right? 384. That means 384, 65. What was the value you'll get? 15, 10, 4, 405. So the representation of 465 of octal number in decimal format is 405 of decimal number 5. So like this we are going to convert my octal number to decimal conversion. So next conversion is hexadecimal number to decimal number. So for this, how I am going to convert is my hexadecimal number is 6A of my hexadecimal number. I want to convert this number into in form of decimals. So how I am going to do it? That is A into 16 power 0. That means for this LSB bit, I am going to add weight of 16 power 0, and for 6 I'm going to add 16 power 1. That means 16 power 0 is 1, right? That means A plus 16 into 6. 16 6 96, right? 16 6 are 96. That means what is A? A is nothing but 10 and plus 96. That is 106. So this is the representation of decimal number. Like this, we are going to convert any number to decimal number. So if you want to convert any number to decimal number, we'll follow this procedure. And the next one is octal to binary conversion. So what was the highest bit in octal? So from octal, how many bits I can represent? So for octal, I can represent 0 to 7, right? To represent 7, how many bits I need? To represent 7 in binary format, how many bits I need? So to represent 0 0 0 0, for to represent 1 0 0 1, to represent 2 0 1 0 0 1 1 3 0, sorry, 1 0 0 it is 4, 1 0 1 it is 5, 1 1 1 0 it is 6, 1 1 1 it is 7. To represent 7 number, I need 3 bits, right? That means highest. What was my highest bit in octal number? 7 is the highest bit, highest number in my octal number. To represent 7, just I need 3 bits. That means for each and every bit, I need to add 3 bits. For each and every octal number, so I need to add 3 bits. For what was the representation of 7 in binary format? 1 1 1. And what was the representation of 4? 1 0 0. And what was the representation of 2? 0 1 0. So this is my octal number. To represent octal to, how to convert octal to binary conversion, just to will add for each and every digit, we will add 3 bits. So this is how we are going to convert octal to binary. And the next conversion is octal binary to octal. So how I am going to convert this binary number to octal is just will club 3 bits. So I'll club these 3 bits as one, these 3 bits as one, and these remaining 2 bits will be um, clubbed as one. So what was, if I club these 3 bits, what was the value I'll get? So I'll get 0 1 0. Representation of 0 1 0 in octal format is 5, and for 0 1 0 it is 5, and last one is 0 1 0 1 is 1 and point, and here from here, so how I need to club 3 3. So if I club 0 1 1, what was the value I'll get? 1, and next one is 1 0 1, it is 5, right? So the representation of this 0 1 1 0 1 1 0 1 point 0 0 1 1 0 1 is of binary number is 155.15 of octal number, right? So this is how we are going to convert from octal to binary. And the next conversion is hexadecimal number to binary conversion. So to represent, what was the highest value in hexadecimal number is f, right? So to represent f is nothing but 15. So to represent 15, how many bits I need? 1 1 1 1, 4 bits, right? To represent 15, I need 4 bits. So that means highest, to represent each and every bit, we need 4 bits in hexadecimal format. That means what was the representation of 4? 0 1 0 0, right? And what was the representation of A? 1 0 1 0. And what was the representation of C? And we have point here, I'll keep point. And what was the representation of C? 0, sorry, 1 0 1 1. And what was the representation of 2? 0 0 1 0. So this is how we are going to convert hexadecimal format to binary form. And the next one is binary to hexadecimal format. For this, what we are going to do is we'll club 4 bits. Here 4 as 1 bits, and here 4 as 1, and here this 4 as 1, and this 4 as 1. So before the point, we need to go from left to right to left. After the point, we are going from right to left to right. Okay. And what was the representation of this? This is 7. And what was the representation of this? So this is B, right? 8 plus 2 plus 1. That means 10, 11. The representation of 11, what was the value? B. Point. And here it is 8 plus 4 plus 1. That is 12. 12 plus 1, 13. Representation of 13 is D. And representation of this is 3, right? That means binary to hexadecimal conversion of the above number 1011011011 of your binary number is P7.D3. So this is how we are going to convert your binary to hexadecimal conversion. And next one is hexadecimal conversion to octal conversion. How I am going to do this is, so I am going to convert this hexadecimal number to binary first. Binary, we know how to convert hexadecimal conversion to binary conversion, and this binary conversion is getting converted into octal. So this is a processor. This is a procedure that I will follow. Convert hexadecimal number to octal number. So A3. So what was the representation of A3 in binary format? A is 10, right? 1010, and 3 is 0 0 1 1. So for this, what how I'm going, this is representation of binary number of your hexadecimal number, and this number I want to convert into octal number. How I'm going to do? I'm going to club 3 bits here. 3 bits. So if I club 3 bits, what was the value at here? 0 1 1. That is 3 1 0 0. That is 4, and here it is 1 0. 1 0 representation is 2, and the value is 243 of your octal number. Like this, we are going to convert hexadecimal number to octal number. And the next conversion is octal to hexadecimal conversion. How I am going to convert? So this octal number I will convert into binary format, and this binary number is converted into hexadecimal format. So what was my given number here? 237 of 64 of your number, octal number. So I am going to do, so I'll write for 3 bits. So what was the representation of 2? 0 1 0, and representation of 3 is 0 1 1, and representation of 7 1 1 1 point, and representation of 6 is 1. Representation of 6 is 1 1 0, and representation of 4 is 1 0 0. So this is the representation of octal to binary representation. So if I convert this binary number, if I want to convert binary number to hexadecimal number, how I am going to? Just I'll club 4 bits, right? Here these 4 bits as 1. Here it is 1. If we can leave that, and here this is as 4, and here this has 4. So how I am going to do here? So what was the representation of all ones? All one is F, and here it is 1, sorry, 8 plus, and here it is 1, it is 9. So here it is 9, and here it is 0, and point after, what was the representation, hexadecimal number representation of 1101? 1 1 0 in 1 is nothing but 8 plus 4 plus 1. 8 plus 4 plus 1, 1 1 0 in 1 is 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 1, 1 12, 13. 13th representation is D. And after that 0. That means 9F point D is your hexadecimal number. This is how we are going to convert octal number to hexadecimal number. So this is all about conversions. So totally how many conversions we have done? So for decimal to any another conversion we have 3. For octal to any other number to decimal we have 3. 3 plus 3 6, and octal to binary 7, binary to octal 8, hexadecimal to binary 9, and binary to hexadecimal 10, and hexadecimal to octal 11, and octal to hexadecimal 12. Totally we have 12 conversions. So like this we are going to convert one number system to another number system. So this is all about number systems.